Yeah, so let's finish up talking about state machine code. Okay, and I think it was 2 years ago, an ex-student of mine got a job at this, I forget the name of the company. Where is my PDF? Right here. And let's zoom in a little bit more. She worked for me as an undergrad and then went and did her master's degree at Stanford. She was actually a gymnast here at U of I, a walk-on gymnast. Kuri Suminami or something like that. She was a Japanese. Anyway, just wonder if anybody had known her. But this company made this little robot called Kuri. K-U-R-I or something like that. Yeah, K-U-R-I. Well, it was kind of fun. They went out of, well, they didn't go out of business. They decided this product wasn't going to fly. And so they had like 40 prototypes of these things. And she said, do you want one? And I was like, well, okay, sure, I'll take one. And it was a little creepy. I had it running at my house for a while. The idea of it was you could say, you know, like Alexa, you could say, hey, Kuri, go to the kitchen. Okay? And it would, you know, you first took, you first with your iPhone, tooled it around your house and it generated a map. So it was using all this great stuff of ROS on a Raspberry Pi. I believe there's even a Raspberry Pi inside this thing. I need to take it apart. It's broke right now, so if anybody wants to, over Christmas break, come in and take it apart, you can come and talk to me and you can do it. Anyway, I can't get it to boot. It just, you power it on and it just doesn't go any further. But for about 4 weeks it worked at our house. It was kind of fun. Like you'd say, only wake up. We put it to sleep most of the day. Only woke up like at 4 p.m. till like 9 p.m. And its job was to go tool around the house. And then when you wouldn't tell it to do anything, it would just kind of search around. And then it would take pictures. And the idea would be to put it up on your Instagram or something like that. It's kind of creepy, right? You don't know when it was going to take pictures. The funny thing is, it did an okay job sometimes finding us and taking pictures, but most of the time, it took a picture of the TV. So I guess that tells you what my wife and I do from 4 p.m. till 9 p.m. No, we don't. But anyway, it takes pictures because that was the biggest motion that it was seeing. Anyway, so now it doesn't work. I've never taken it apart, but anyway, can kind of see why it didn't become a product. But anyway, so it was we're going to try to sell it for like $700 too, and I think that's another reason it just didn't fly. So anyway, so I got this back then, and I was teaching on state machines, and so I thought I'd put together kind of like a state transition diagram for maybe what this Kuri does. You know, there's a lot more detail to this, obviously. But in this case, I just had 4 states, okay? And I called them state 10, state 20, state 30, and state 40. Okay, and so you can see all the different transitions that I came up with. You know? So this commanding it to go to the kitchen was actually, that was the coolest feature, I thought. You know, you could just say, go to the bedroom, go to the kitchen, and all this kind of stuff, and it actually do it. That was a really neat feature of it. And so what do we have? We have actually going to that XY point. That's a state. If it did see obstacles, it did have a LiDAR into it, a very inexpensive LiDAR. So that's how it mapped the room and everything. So it could sense that. But it was only on one plane. You know, the cheaper LiDARs are just in one plane, not the 3-dimensional that go up and down. And so it did have a bump sensor, just like a vacuum cleaner, right? Like those, what are they called? Roombas. So it did have that. So when it hit the bump, you know, it saw like a chair leg or something like that the LiDAR didn't see, or who knows, whatever it found. So it did have an avoid obstacle state. Now what it did is when it hit the bump sensor, it kind of looked like, to me, when it hit, it would back up, and I'm assuming it just kind of said, okay, there's an obstacle here now, and it would assume it was a certain size and try to avoid around it, you know. So it did that pretty good too. That was pretty nifty about it. And then that's right, avoid obstacle, but if the bump sensors hit, you move backwards and then go back to avoiding the obstacle with a new object in your way. And then there was the state when you weren't doing anything, we were watching TV or whatever, and it would make little noises, you know, or whatever, and I'll be looking around and doing things. Now I didn't put in taking a picture and all that in this state transition diagram. But great. And so remember, when we draw these lines from one state to another, these are all the if statements that should be inside your C code. Okay, inside that state. Remember what I talked about last time, and we're going to look at the C code in just a second. I don't want, when you're making up state machine code, you're going to have your switch case. So you're going to say if state equals 10, do this. If state equals 20, else if state equals 20, do this. Else if state equals 30, etc. What you want to keep yourself from doing is making all the decisions which state you're in above the state machine code. You want to do all your logic, all your thinking of what state I need to be at, the next sample rate, you want to do it inside this state. So in other words, here, what do we got? This guy's if statements. We only have two ways this guy gets out of wait for new command. Well, only one way to get out. So just two if statements. One is no new command has come in, so stay here, right? Otherwise, if the command was issued, right, and it's knowing to go to the kitchen or whatever, then it would be commanded to go to that XY point, right? And so we would transition from waiting for new command up here to move XY to a new position on the floor or in your house, okay? And then the other ones, like what's got more if statements? Well, this has got a bunch, right? So there's a lot of transitions out of the move XY. If you got to, so if Kuri was spoken, right? Okay. If the XY point was reached, if the bump sensor is hit, if the LiDAR senses an obstacle close to it, right? So there's a lot of transitions out of the move XY, because you don't want to just run into an obstacle, do you? You want to get out of that move XY if something's happened. All right, so let's kind of think what that looks like. Now, I'm not saying it has to look exactly like this in your C code, but this is what I highly recommend. So here is your, more than likely, with a robot car, with the SegBot, you're going to have a servo loop, okay? Something happening at a certain rate. Now, I wouldn't say this periodic function of your state machine has to be every, say, 4 milliseconds if that's your servo loop. You could possibly do it at a slower rate. You could think about that, if that's reasonable. Maybe you do it at the rate that you get your image from the camera. Depends. It depends on your system. You'll have to see. The good news is we have plenty of room for code on our breadboard. So don't worry like you're going to write too much code unless you start getting into looking at large sets of data. Okay? That's only the time. Like if you do get into measuring a tone or finding a tone, multiple tones with the microphone, we are going to have to think about that the code to run the FFT, which I have an FFT starter file. If you want to do that with tone recognition, make sure to talk to me about that. We are going to collect 1,000 data points, 1,024 data points for that FFT, and then go and run the FFT algorithm. Well, you got to know that FFT algorithm, it doesn't take a huge amount of time, but 1,024 data point FFT is going to take about a half of a millisecond. Not terrible, but probably not something you want to put in your servo loop that's happening every 1 millisecond, because it's taking half the amount of time. So we'll have to, if you do the FFT, we're going to have to think about where that code goes. But this simple state machine, there's not a lot to it here. You could put this in your every 1 millisecond code or your every 4 millisecond code. It would be fine to put there. So anyway, just keeping that in mind. So what do we have? Remember this switch statement in MATLAB, in C, right? You switch on the state variable, and then you have case, and if it's 10, then you'll do all these instructions inside case 10 until you get down to the break. That's always the little catcher with a case. You always forget to put this break at the end. Really, from this colon down to the break is like you put squirrely braces in an else if. Right? It's telling what all you do in a case. Why they didn't use squirrely braces is a good question. I don't know. Someone came up with this years and years and years ago. And then same thing here. Case 20, oh, I went fast. Case 20 and then case 30, the code you're doing, inside and down to break, etc. Okay? Now, what also is happening? There are some things that need to happen every sample rate. Okay? That's this stuff up here. Or I guess it could be after the state machine too, depending. But, right, we need to be constantly checking for a voice with the Kuri robot. That's got to be happening all the time. Calculate, what do you do with the motor control? What speed, what bearing do you go at? All that kind of stuff. Our PI control loop, those things. That has to happen every sample period. Read in all the sensors, right? So that you got to make decisions with the sensors, don't you? Okay? So pretty much all the code we've written up to this point in the lab, in all our labs, balancing a segbot, telling the robot to go at a VREF and turn value and all that, that still needs to happen every millisecond or every 4 milliseconds, right? What you're going to be adding is some decisions what to do. You're in the state machine, like with the robot car, you're going to make the decision, what VREF and what turn do I need to apply to the robot. Right? The simplest one, we're coming up to a front wall. Boom, we're in front of a front wall. We don't want to keep on going forward, do we? We want to go into a mode where we turn either to the left or right. Okay? That is a decision that would be made inside the state machine. Because we will be switching between different things. Right wall following, then front wall turning, all right? Deciding if we turn to the left or to the right, okay, when we get to an obstacle. That'll be dependent on what our distance sensors are telling us, right? If you have 3 sensors, one pointing forward, 2 pointing to the right, and one to the right, one to the left. If the one on the left is closer to the front wall, then you probably want to turn to the right, maybe. I don't know. That's a decision you need to make. Okay? Those are the kind of decisions you're making here in the state machine. You also hear, the other thing is the state machine may be going faster than we can collect our vision data, for example. That'll be a good possible one. You're getting camera data probably at 30 hertz or less. But what are you looking for? Well, the big one, if you are following a color, looking for multiple colors, we're going to get centroids in pixels. Where is that blob of green in our XY row column coordinates of the camera? Okay? And you'll make some assumptions. Maybe that blob is always on the floor, right? Or a ball on the floor. So you can make some choices then. By when that centroid is on a very low column, that probably means you're pretty close. Or if you're seeing a lot of pixels, that could also mean you're really close to the obstacle or to the object you want to get. And then you make a decision to turn towards it or something like that, right? Okay, so we'll be doing this. You guys will come to me with your project, and we'll sit down and we'll think about all the decisions that need to make. You will sit down and think about all the decisions that need to be made, right? Okay. Now, then, how do you work here? Then the whole goal, and what I'm going to try to get you to do for the most part, is your decision making. Notice, what do I do? Inside case 10, it's commanding the Kuri to go to XY coordinate. So here, it's doing the path planning algorithm and all this kind of stuff to go from one place to another, whatever the Kuri's doing to get to the XY points. But then every time we adjust our control to go to that XY point, we're also checking these ifs down here. And what this is saying is, if we locate an obstacle, let's go to state 20. If the bump sensor is hit, we're going to go to state 30. If it hears spoken, hey Kuri, we're going to go to state 40. Okay? And then also, and then there's another one, go to 40 if the position is reached, right? Because that means we're done, we're there. finally, technically this isn't necessary, is it? We're already in state 10. To make it obvious, when none of these conditions are true, we want to stay in our current state. And that's really important, okay? And again, what are we saying? We're saying that, because what's going to happen, we'll get into case 10, and then when we break out of here, we break out of the whole switch statement. We don't immediately, say we said we want to go to state 30, it will not go and run immediately the code down in state 30. Instead, it'll come in the next sample period, right? And run state 30. That's a concept you got to get in your head so it doesn't confuse you. And again, because our sample rate's so fast, that usually is not an issue. You've made that decision, and 4 milliseconds later, you're going to do something with that decision. Okay? Now, if it becomes that little lag is important, then you would probably have to do something right here before you set it to state 40, but then you do some kind of whatever, initializations or whatever is important right here in that, when you make that transition, instead of doing it down inside case 40, because you're not going to get there until the next sample. The other thing I like to do it, and you could do it a number of different ways. I've seen people also have like a variable first time, or something like first time into the state, or anything like that. There's usually, when you transition from state 10 to state 30, there's usually some initial variables you need to initialize to be at 0, to be at certain initial conditions when you get into state 30. Okay? So that's why there's these variables like state 30 first time or something like that, right? And you would come in there in state 30. If it's the first time, you would do some initializations and then set that first time flag to 1, so you don't come, when you come back into state 30 again, the next sample, you don't do those initializations. So personally, I don't like doing that. You get all these extra first time variables. So I like to do all the initializations for state 30 right here in state 10 before the next sample period when I get into state 30. Does that kind of make some sense? So you'll think about that, what needs to be done. But the whole point is, when you get into doing this state machine, I kind of want you to look at this, read these comments, and kind of see what I'm trying to say. And that's initialize any variables needed for state 30. And I say very important, because usually it is, to make sure everything's ready to go when you jump to state 30, the next sample. Okay? All right. And, the flow looks the same. So down in state 20, again, this is obstacle avoidance. So whatever the robot needs to do every 4 milliseconds, let's say that's our sample period, to path plan around the obstacle. Okay? Whatever that is. But then also every 4 milliseconds, we're checking, do I want to stay in state 20? Or has my sensors or time, right? Sometimes you may want to just like a little delay, and that's kind of nice. You could have a state that sits in there for like 2 whatever number of seconds, half a second in a state before you go to another one. That could be something you do too. That's how you could. I don't like it a lot, but you could if you find you want to turn for like a half second. You could have a state where you do that. Okay. Anyway, so you can think about all the different states you could have. But again, whatever is needed for path planning, then make the decision. What state do I do the next 4 milliseconds? And again, that'll all look the same for case 30, same thing, checking those ifs, and case 40. And you notice how remember we saw in our state transition block diagram that 40 had less if statements, didn't it? There was actually just one for 40. To get out of 40, a new command was issued, right? When we're waiting for the command. And so that's why, all these if statements, and it gets really ugly, all these if statements would have to be put somewhere before the switch case statement. You do all these ifs to decide what state you do. So it's much cleaner to put that decision making inside the state. And I know I'm repeating that over and over again, but it's really important to get that concept in your head when you're programming this. One neat little thing, you know, unrelated kind of to a robot, but state machines are very useful in serial communication too. You can set up a protocol. Some of you are going to see, if you're working with the Raspberry Pi, create a protocol. We're going to have to come up with a protocol with the MyRio too. The breadboard, the F28379D processor, can get interrupted. It is interrupted when every character on the serial port comes to it, right? We get an interrupt for every character. Well, we need to create a command so that the Raspberry Pi or the MyRio can request data back from the breadboard, right? We also need a protocol so that the MyRio or the Raspberry Pi can send data to the breadboard, right? So it receives. And we've made a simple one for, and there could be some little flaws with this, and we can walk through this, but for example, if I send, right now the protocol to the Raspberry Pi is if I send asterisk asterisk, then the Raspberry Pi knows there's 8 more bytes coming down that are the 4 bytes of one float and 4 bytes of another float number. Okay? So what's happening in that serial port code, it's in state 0 first, waiting for a character. If it sees an asterisk, it says, okay, go to state 3 or whatever it is. Okay? Then the next character that comes in, if it's not another asterisk, maybe for some reason we got a fictitious asterisk or whatever. Let's say you got asterisk and then exclamation mark or whatever, who knows. It would say, oh, that's not an asterisk, let's go back to state 0 and start waiting for characters again. Okay? But if it gets an asterisk in that code and then goes to state 3, and then when we come in there with the next character, we're in state 3, so we're down at state 3 of the state machine, and we get another asterisk, it's like, we got 2 asterisks, so now I want to go to state whatever, 4, or whatever it is, and in state 4, we're going to stay in state 4 until we've received 8 bytes. Shove, shove, shove. We'll get all 8 bytes of that, and now we've got our 2 floating point numbers because there's 4 bytes in each float. Does that kind of make some sense? So that's another place to do state machines. Okay? It doesn't have to be just in navigation of the robot. So it's a good way to do some of this stuff. Okay, great. Any questions about that? Okay. So there's quite a number of you working with the MyRio, and that's great. I'm excited about that. Getting those working. We haven't been using those in the class ever since the COVID shutdowns or whatever. I think 2019 was the last time we used them. But so we need to think about the same kind of code in LabVIEW. Okay. Now, one way to do it, and if you'd like to, you can. It gets a little bigger. You could use a formula node. Okay? In that formula node, you could bring in your state, and then you could have a bunch of if, else if on all those states. And then output your state and things like that. You could do it that way, but the way kind of National Instruments recommends is with a case structure. Okay, so that's the way I'm going to show it. If you don't like it as much, you could think about doing it with a formula node. All right, so let's see how this works in Citrix. All right, so I'm going to go here. Where's my VI? There we go. All right, and I'm not going to get this all the way done. I did last night put together a little state machine that does transitions between different states on time. Right now it's just on time. I don't have any sensor information coming in. And I'll put that up at Box with this lecture. But let's just get this started on what it's going to look like. All right. So let's give ourselves a good amount of screen here. And what we want to do, right, even on the MyRio, we want to have some kind of loop. Okay? So we're doing things, we're checking sensors at a certain rate. or as fast as it can, however we decide to do that. And so first thing we put down is a while loop. But as I said, on the MyRio, we can also put down a time loop right here. That's this guy to the right. And on the MyRio, we can actually specify that this time loop runs on just one processor. And the cool thing is that could be running on one processor, and your vision, your camera code, could be running on a second processor, and they don't interfere with each other as bad. Okay. Anyway, so we could do a time structure, and we could tell this loop to happen every 10 milliseconds, every 1 millisecond, whatever we want. The MyRio is a real-time device. So, but let's just do the while loop right now. Okay. Go to here. All right. Then inside here we will put a case structure. Structures, case structure. All right. So right now, our case comes into the question mark right here. We have right now by default a true and a false. You can look into this. There is a, I get confused, and so I always don't use them. I should though. There is a thing called a enum constant right here, and you could go look at, just Google some stuff on case structures, and you'll find probably an example of someone in YouTube using one of these enum constants. So in other words, if we want to make case 0, 1, 2, 3, 4, right? A enum constant allows us to give those numbers a name, like follow and go and stop, or whatever you want to call them, right? That's what an enum does. You can check that out. I'm just going to stick with just numbers right now with my states, okay? All right, but anyway, so what you can do here is create your different states. Now, this is always tricky a little bit to figure this out. If I go here and add a case after, and I'm just going to call this case 2. Yeah, and see, it makes it a character string. Ah, see, I knew it was going to do this to me. Let's see if I can fix. So it's probably because these are false. Let's go here. What if I make this guy false 0? See, it puts it in quotes. Let's see if I can fix this. This was doing this to me last night too. 1. All right, now what if I do the following? If I bring in first a constant. So I'm going to go here and get a numeric constant. So we have an initial condition. Now, what's also going to happen here? So again, what do we need to tell this case structure? Every loop, we need to tell it what state to go into, right? So whether that be every 10 milliseconds, let's call it 10 milliseconds right now. So every 10 milliseconds, we're going to loop back. We can put a wait, right? To make that 10 milliseconds, we could just put a wait right here. Timing. This isn't exactly 10 milliseconds, but it's pretty close. And we could go constant and make this 10, right? Okay, so that's 10 milliseconds. And so every 10 milliseconds, we're going to come back, in a sense, to the beginning of the while loop and run the case structure again. So the best way to save the state, and you did this with one of the LabVIEW exercises, is to make a shift register. So we're going to go here to add a shift register. And what you do is the new state, it could be the same state, but the new state you want to use the next 10 milliseconds, goes into the shift register here, and then comes out here after the while loop is done with its one loop, right? The next loop, the new state or the old state will come out of here. Now what you can do is you can give the shift register an initial condition. Okay, so 0, let's say we want to start it in state 0. If you wanted to start at a different state, you could put that number right there. Okay, and then I'm going to bring the actual state into there it goes. Yeah, that did it. See how it changed those now from characters to just numeric values, 0, 1, and 2, by putting the correct type into the question mark. Okay. Yeah. It doesn't have a little. It does have a coercion dot there, but anyway, see that little red dot? I don't know if you can see it up there. There's a little coercion dot, but I think that's okay. All right. So we have these three states. Okay. So now what do we want to do inside here? Let's say let's just print something. There are some rules. Let's see here. Let's go and create a string constant. All right. And now you probably, yeah, I think what you got to do, so let's just call this one follow, who knows, and we're going to put a indicator, create indicator, and I'm going to put it outside of the case structure for now. Okay, so we want to print follow if we're inside case 1, and inside case 0, let's call it whatever, we'll call it go string constant. But anyway, you know, what's going inside here is anything you want to do, right? If you want to go look for a blob of color with the camera, if you want to switch, another thing you can do with the state machine, a lot of you saw me yesterday go and create a quick little application with the camera and the MyRio. You may make, because you want to look for maybe green, and then the next 10 or 30 milliseconds, you'll go look for red, and you'll go back and forth or something like that. You can change inside your state machine the range of your color, which was in the HSV color space. So that's something that could be transitioning in your state machine. All sorts of things could be inside here. Okay, let's just call state 0 go. And put it here. And then finally in state 2, let's call that guy stop. String constant and stop. All right, bring that up here. All right. Now, what do we want to do inside these? Let's keep it basic for now. Let's say that we want to just be in case 0 for a little bit longer. Let me see, that'd be 10. Would that work? Let me think. Yeah, I think this will be all right. So I'm going to put another delay. I'm wondering if these two delays will hit. Well, worry, but I don't think they'll matter with each other. We'll find out here. Let's say when we get into state 0, we just want to stay in here. This is really basic coding, of course. We want to stay in here for a little bit of time. Let's stay in here. Oh, not a control. Change to constant. Can I do that? Change to constant. There we go. Let's stay in here for 3 seconds. Okay. And then in state 1, we'll stay in here for 4 seconds or something. Create timing. Wait. Create constant. So 4,000. And let's see. And then state 2, we will stop. Let's not stay in there at all. Let's just go right out. But anyway. So what do we want to do in these? We want to transition between states. So our if statements here are going to be pretty basic here. We just know we're going to come into state 0. We're going to stay there for 3 seconds. And then we want to transition to state 1. So I can come here and say numeric constant. Right, and just do 1 here, and bring this to our shift register, right? That's the new state. And then in state 1 here, we will, again, numeric constant. We want to go to state 2 and put that here. Do you guys see this open? You probably have seen this when you've been programming. You see that open hole in this port or whatever you want to call it? That's just saying we don't have something going into that in each of our case structures. So you want that dot to go away, the white. All right. And then finally, we'll just go, this doesn't really matter because we are going to stop here, but let's go ahead and give it, we got to give it something. So we'll give it another numeric constant. And we'll just leave it, we'll go to 0, that's fine. But in this case, we actually want to stop. So we're going to do a Boolean constant, true, and this will come out and go to the stop, won't it? Okay. And the other ones, we're going to have to make that false. So we don't want to stop if we're in case 0. So another Boolean false. Oops, Boolean false. Oops. Did I mess up? Can I get it? Ha! Control B. Control Z. Don't do that. Control Z. There we go. Back down. I should have brought my mouse. There we go. And one more false in state 1. Boolean false here. All right, is it? Hey, no, it's broken yet. Let's see what it doesn't like. We're gonna run. What does it say? Oh yeah. So what happens here? You got to make one of the case structure, one of the cases, the default. And so you can right-click on here and make this the default case. There we go. And so that's just if something comes in here that's not 0, 1, or 2. It'll just go to 0. Okay. Now we're ready to run. Let's see. What do we have on the other side? Not much on our display here. We've got, what we could do is look at our state. That'd be kind of nice. So let's put an indicator here. Create indicator. Numeric. Oops. Right there. Let's see if we can, well, yeah, let's see if we can put an indicator. I always forget if you can put an indicator inside the structure. But I think it only changes when, yeah, it would only change when we're inside this. So I think it's better to leave it out. I think so. Okay. You could play with that. You could also, if you need to see something that's going on inside the case structure, I believe you can create a local variable and assign the local variable inside the case, and then in another while loop that's running on another core or whatever, CPU core, you could display that local variable. And that's kind of a way to see what's going on inside the case structure. Well, let's just try it. You can, I think, put one inside here, but it'll only update. Create indicator. It'll only update when you're inside there. So, all right, let's see what this does. Control E. So this is numeric 2. Right, so this is our other case. All right, let's see what happens. So we're in follow for 3 seconds. Now we're in go for 4 seconds. And then we stop. And our final state was stop. And then our numeric, constant. And then see, this only updated to 1. It didn't go to 2, right? Because it's inside only the 1 case structure. Oh, I'm sorry. It's only inside. Oh, yeah. Of course that's 1 because I'm assigning it 1. I'm sorry. But anyway, yeah. So you can put a numeric in there, but it's going to only be assigned when you're inside that. You know what? Let's do a better one here. Let's move this numeric over to here and watch the counter. Oh no, that's this. You can watch the counter of the timer. That would be better to see if when it's actually running. Let's see if that works. So that's in 0. So let's run this. Control E. Oh, come on. Escape. Control E. Now numeric 2 should count up to 3,000. Maybe not. Oh, there it goes. Oh, okay. So it's actually in units of seconds. So it counts, maybe. I don't know. What is that in units of? Oh, no, that's the system time. Yeah, these timers, they're giving you the number of milliseconds since your computer started that day or whatever, since you booted. That's usually what they give you in this time. And so that's why it's a huge number there. Anyway, how's this going? What do you think about this type of case structure thing? Okay. To make the decision on what to do each case, you could, I like it, you could make your if statements with another structure, the formula node, right? And what that would entail, you got your if statements inside here. If you want, I just kind of like it because, this is all the things you need to do in that state. And then the decision making here of what state to go to could be in some nice if statements if you want. You can do it with all sorts of other conditions. But what you have to know is you have to then there is no such thing. I guess you could make a local variable, but it's not best to do it. Your state is inside this shift register. In a sense, the shift register is making it a global variable. So what you can do is you have to add an input into this, and you would call this state input, and that's what comes in from here. So whatever state you're at, okay? And why do you need this? Because we've got to create a state output. Add output. And so state output, you can't just like bring state input into this state here. So do this, and then up to your wire, and now inside your if statement, right? If whatever, if sensor, maybe you have some kind of sensor coming in here, some input, create input, sensor reading, who knows? If I can type, sensor. If sensor greater than 100, who knows, right? We could say state output equals whatever, 2, right? Go to the next, go to the state 2. Else, or else if, however you want to do it, else, and I need a squirrely there, don't I? We keep it the same, and we could say, we could know what state we're in, or we could just say state equals state input. So it stays the same, in other words. There's no way to have state input here and also state input here on your output in these little formula nodes. So you got to do this setting what state input settings. You have to set state output in each of your if parts of your if statement inside here. Okay, but again, you could also just do conditional statements. That's another way to do ifs, right? You can also create this state output by going here and doing all these different comparisons, less than, greater than, and there's even there's a nice block for selecting which, you know, true or false or 1 or 0 and all that kind of stuff. So it depends on how you want to create your logic of making the decision every time inside this case what the next case should be. All right? So and the thinking is very similar to your C code. Okay? Great. Very good. So today